Okay, so this class, we want to see how best to answer this. So the whole idea or the whole concept of this question is based on how to calculate the moment. So if you look at the first question there, they want us to find the moment produced by a force F about a point D. So here, they are actually specifying that they want us to express the result in Cartesian vector form. So how do you determine the moment of a force about a point? So the moment M of a force about a point, let's say D, so of course moment is a vector, is going to be given by the cross product of the displacement from the specified point, in this case it is D. So from that point D to any point where the force is acting. In this case, it is going to be B there. So the displacement from D to B, then cross the vector force F. So this is the formula we're going to use to determine the moment of the force F about the point D. Now here, of course, we have a few random values that we're going to use. So for our case, I have picked F to have magnet F1. So that's basically just F. I can use F1. But in the diagram there, we're seeing F. So let's go with F. So the force F is given to have a magnitude, in this case, of 500 newtons. Let's take A to be 1, negative 3, 4. The displacement vector RAC to have those dimensions. And then the angle theta to be making a 30-degree angle. Now, how do we solve this question? Well, clearly all we need is to perform a cross product here. But for the cross product to work, we must first find the two parts, the displacement vector RDB and the force vector F. So let's start with the displacement vector RDB. How do we get RDB? So to get RDB, the first thing that we need to find is the point D, the coordinates of the point D, because RDB will be a vector that runs from D going all the way up to B. So we need to figure out what the coordinates of D are going to be. The question gives us the coordinates of A, and according to the question, we have A as 1, negative 3, 4. So 1, negative 3, 4. This is what A is. Next up, the only other thing that they give us, they don't give us C, they give us the displacement vector from A to C. So they give us RAC, and that is specified here. So we have RAC, and according to this, RAC is given by this. Now, what I want to do first is figure out where C is. So how will I do that? So to understand where C is, we know to say that if I wanted to find the displacement vector from A to C, or let me start by saying, if I have 2 points A, and then say A is x1, y1, z1, and another point C to be x2, y2, and z2, then the displacement vector from A to C will be given by the difference, the final minus the initial. In x, it's x2 minus x1. In y, I mean, it's going to be y2 minus y1. And then in z, z2 minus z1. But for our current case, our A is defined by this, and our C, we don't know what our C is. So our C will take x, y, z. So again, we're still moving from A to C. So the final is at C, the initial is at A, meaning our RAC can be found by final at C, that is x minus initial at A. We have 1 there. Plus, again, final at C, y minus initial at A. This one is -3. So that negative with this negative makes a plus. In the same way, Z final at C, initial at A, minus Z1 at A, that's a 4. So you have -4, and then this is K. But if you recall, the question does tell you what RAC is. It gives us the values for that. So RAC is expected to be this. So we'll say that, okay, when the right-hand side is simplified, it will actually simplify to give us this solution. So this is what we're going to end up with. So from here, easy. Equate everything that has an I to what has an I on the right-hand side. So this gives you 2 being equals to x minus 1. Eventually, x will be equals to 3. In the same way, here, equate everything with a y. We see that we have 2.5 being equals to y plus 3. And from here, we have y is equals to 2.5 minus 3. That is minus 0.5. In the same way, for z, we have minus 4 equal to z minus 4. When -4 goes the other side, we get z is equals to 0. So this becomes what we have. So our C will actually have coordinates 3, -0.5, 0. So this is what we're finding. Now, how does this help us? Why was it necessary for us to get C? Well, here's the trick. The question tells us that D is the midpoint between A and C. So since it is exactly between A and C, that is where D is, then all we have to do is now get the midpoint of A and D, and C, I mean. So our A is here, and our C is what we have just found. Now, how do you get the midpoint between 2 points? So, midpoint, we have add the coordinates and then half them. So we have 3 plus 1 over 2, comma, -0.5 minus 3 over 2, comma, 0 plus 4 over 2. So the first one is 4 over 2, which is just 2. So for the second one, we have, this is basically just going to be -3.5 over 2, comma, 4 over 2 again, we get a +2 here. But that middle one, what will it simplify to give us? So I can even say 2 into 3, that's ones. 2 into 15, we can say that is 7, remainder 1, and then into 10, that is 5, 1.75. And then this is a 2 there. So we have the coordinates of the midpoint, and the midpoint is D. So therefore, the coordinates of D have come out to be this. Now that we have the coordinates of D, we are close to finding the displacement running from D to B. But clearly, we need to figure out what B is. Because if we know what B is, we can now get the displacement vector from D to B. And this displacement vector is the one that we're going to use in this position when trying to get the moment we are looking for. So how do we get the coordinates of D? Well, here we can actually just look at what we have here in terms of the lines. We see that the x coordinate as you go towards D is already given, and what is already given is the y coordinate, and the y coordinate is 3, 6. So the point B has y coordinate 3, 6, and it's in a positive direction. See, the x coordinate will be here. For starters, it is pointing in the negative direction. So expect this to be a negative number. But what number will it be? Well, firstly, this is right angle. So you're seeing a right angled triangle. And to just show you, the right angled triangle will be this one here to here and then to there. So that is our right angled triangle. Now remember, the angle at the bottom here was given in the question. And according to our question, that angle is 30 degrees. So by sine, I want to get this. Let me label it as x for now. We can actually use tan there. By tan theta, opposite is x, adjacent is 3.6. When we cross multiply, we get x is equals to 3.6 multiplying tan 30. What will be the solution to this? Can you guys try this very quickly? Okay. Now 2.08. Once you know what x is, so it comes here, remember it is negative. So that's 2.08. Now we need to find z. But where is z? Z has to be parallel to the z-axis. Z is here. Remember where we're coming from? Remember where we're going. Here's where we're going. And here's what we've done first. We said the y component will be from here to here. The x component will be this one we're just from finding up to there. So the final one will be this one that takes us now finally up to B. But what is it? So to find that, the first thing you have to do is to observe that that line is actually part of a triangle. Which triangle? So for this line, you see that if you look at this dotted line here, coming up to O, and this dotted line now going up to B, and the vertical line from E to B, which is the one we're looking for, notice that these form a triangle. And this triangle is actually right angled as well. So based on that, we can actually use this triangle to understand what is happening. But to do that, we will actually first need to figure out what this bottom line is, this bottom one. We need to first know what this side is. Remember, this side was already part of this bottom triangle, which we were already discussing earlier. So I'll use this angle and the 3.6 to determine what this base line here is. So I can label this line as, maybe can even use gamma. So to find that, we can use cos theta is equal to adjacent to the angle is the 3.6. Then hypotenuse is that gamma I've just introduced. The angle is 30. So we're going to end up with gamma is equals to 3.6 divided by cos 30. What will be the answer here? Okay, so 0.16. So you get just around the property and so on. Because points up, we expect it to be positive. Therefore, 0.16. So this becomes sorry, left here. But what that we're actually finding here is the bottom one down here. So after finding the bottom one down here, look at what that triangle in blue gives us. You see, the triangle in blue, let me do it from here. Look at it as if it is this one. But part of this triangle in blue, or within it somewhere, you observe that we have this side, which is 1, this side, which is √3, And this is the hypotenuse somewhere there. Now observe that the √3 side is actually parallel to this side, while this is parallel to this side. Now, based on that, the two triangles are actually similar. The angle here is the same as the angle here. The minute these two lines were parallel, that statement was true. So, based on the fact that these two triangles are actually related, we can now make a comparison. What comparison? Since the vertical part of either triangle, I'll do it from here. The smaller one is like it's somewhere here. So since this is 1, if this is the vertical part is 1, then the base will be √3. So I have this 1 over √3. This must be equal to, this vertical part is what I'm looking for. Let me label it Z. But I am just from finding what this bottom line here is. So what I'm from finding that 4.16. So the base one is 4.16. So since when the vertical is 1, then the horizontal will be √3. Now the question is, what about, so this has to be equal to when the vertical now is Z over the horizontal being 4.16. Do you understand why these two are equal? Do you? Silence means you do understand.
No, sir, can you repeat? I don't understand.
Okay. Look at the triangle in red. I just mentioned that the angle here, if the angle here is theta, then even the angle here must be theta. So let's look at the triangle in red. If I used tan theta, what will I have? I will have 1 over √3. Now, when I do the same thing, but now for the triangle in blue, what will I see? For the triangle in blue, it's tan theta, the same angle, but now we're looking at it from the bottom part. But for the triangle in blue, tan opposite over adjacent. So now it will be opposite, which is Z, over adjacent, which is 4.16. Now, both equations tell you tan. They're saying stories about tan. Since their left-hand sides are all about tan, it implies that their right-hand side must also be the same. So this is how we end up concluding that 1 over 3 is equal to Z over 4.16. Do you get it now?
Yes, sir, but how did you find the negative 2.06?
Negative 2.06. Isn't that from a previous step? This one here.
Yes.
This one we found it here. We're dealing with this triangle here. Remember there we had something like this. This is 30. This is 3.6. And then the x is here. So we did sine 30. Is it not sine? We did tan. Tan 30 is equals to the opposite, which is x over 3.6. This is how we got that. Have you got that?
The plus.
From here, now just work out this to find out what z is. And we see that z will be equal to √3 divided by 4.16. So what will be z here? Sorry, not this. We have to do some, not that. So yes, this is actually not this. Instead, this is going to be z is equals to 4.16 over √3. What will be the answer here?
2.40.
2.40. So we now have z. Why did we need z? it was giving us the coordinate of B. So we wanted to get the coordinates of B. So we have just figured out what the vertical coordinate is. So we had the X coordinate, the Y coordinate, and then 2 point, which one did you give me? It was forward. 40, yeah? 40? Yes. 2.40 as the Z coordinate. Okay, so we're here. So we now have everything we need for B. And remember, we also figured out what D was earlier. So with B and D figured out, we can now determine the displacement vector that runs from D towards B. So again, remember, for displacement vector, it's where you're going minus where you're coming from. We're going towards B, so it will be B, which is minus 2.08, minus, we're coming from 2. This is in the I, plus. Now, we're going towards 3.6, minus, we're coming from negative, so the negative makes this plus 1.75. J, then plus, then we have, we're going towards 2.4, minus, we're coming from 2. So what will be the solution for the first part? So we now have RDB. So with RDB figured out, remember why we needed it? We needed it for this formula here. So this is where we're going. So since we have now figured out RDB, the next one we need to now understand is the force F. See, the question only gives us the magnitude of F. And here, I give F as 500 newtons. So now, how do we find it as a vector, given that the magnitude only is 500? So if F is 500, the question is, what is this as a vector? Now, if you have the magnitude of a vector, to represent it as a vector now, all you need is a unit vector that points in the same direction as that force, then dot it or multiply it with the magnitude of the force. If you did this, what you come up with is the same force, but now as a Cartesian vector. So here, we see that the key part is actually to just find what a unit vector running in the direction of the force will be. Yes, Mila? All right, so, yeah. So we now see that for this to happen, for us to proceed, we must first figure out what this unit vector is. A unit vector that will have the same direction as our force F. Now, how do we find that unit vector? Well, let's go back to the question. The question gives us one important hint or one important detail. So, to understand it, we check out this point. The force F1 acts perpendicular to the inclined plane. What does that mean? It means that this force makes a right angle with that line. It also makes a right angle with this line. In other words, it's like I have a plane like this. So it's like we have a plane like that. So this is the plane in question. Now, what do we see about this plane? According to the question, to this plane, we have a force acting on it. But this force is such that it is perpendicular to the plane. What does it mean? It means that this force is perpendicular to this side of the plane, it is also perpendicular to the side of the plane. Overall, any line drawn to this plane to exactly where the force is passing will make a 90-degree angle. That's what you should get there. But the key concept that you must actually understand here is this. If you have a plane like this, and then you have two vectors that lie on this plane. One vector, let me say one vector is this. I can label this vector as B. And then you have another vector also starting from the same point, going away in this direction. Let's label this vector as A. Now, once you have these two, what you must know is that if you were to cross these two vectors, let's say A cross B. So vector A cross vector B. So this is cross product again. If you were to cross these two vectors, what you will get is a vector C. So here you're getting a vector C, but this vector C will have one key property. It will be perpendicular to both A and B. So you get a vector that points in this direction, perpendicular to both B and also perpendicular to A. This is one property of the cross product that you must understand. And it's the property we want to utilize here. You see, since they say that this force F1 is actually perpendicular to the plane ABC, because of that, we'll try to find these vectors. So remember, the vectors are coming from this point. So we need to find a vector that runs from B going towards A. And we need to also find a vector that runs from B going towards C. So the vector since it is from B to C, this is RBC. And the other one is from B to, this is BA. And the one down here is the one which is RBC. Now, how do you cross them? So we need to find a vector. Let's say this vector is just R. This vector is going to be obtained by getting the cross product of R, BA cross R, BC. So when you cross these two vectors, what you will get will be a new vector R, and this new vector will be perpendicular to both RB. Okay. So yeah, it will be perpendicular to both this vector and this vector. Now, all we have to do is to want to find this displacement vector, because this displacement vector, since it will be perpendicular to BA and BC, it will actually be a vector that shares the same direction as our force F. That is going to be the vector R that we are getting. It will be a vector that has the same direction as our force F1 there. But to find that, we must first find RBA and RBC. So that is our next assignment. Let's begin. How do we find those? Let's start with RBA. Luckily for us, we have already gone through what B is and what C is. So finding RBA is actually very BC. So I have B, C, and BA. Let's start with BA. Finding RBA is easy, but first I just need these. I need A, B, and C. So I'll get B from here. Now I need A and C. A and C are both here. Okay, so with those figured out, now let's start with RBA. So BA, I'll start with A. So final is A. So it would be 1 minus. So it's B. I almost wrote the values from C, but it's B, don't forget. And the first value for B has a negative, which will make this a plus. That's 0.8. Then plus, in the Y, I have at A minus 3 minus, and then at B, 3.6. Plus, I have 4 minus, and then at B, I have 2.4. So now I just have to simplify this. From the first one, we have 3.08. From the second one, it will be minus because both terms are minus. It becomes minus 6.6J. Finally, this side, when we less 2 from that, this is going to be 1.6. You guys can correct me if I've made a mistake there. So this becomes RBA. So we now have RBA. Let's now find RBC. So we're going to use the same technique. We're using these. Let's try to see if we can find it. So the next thing that you now want to do after finding RBA and RBC is to evaluate their cross product. So now we're going to find that vector R, but remember, to find this vector, you must cross RBA, cross RBC. To perform the cross product, what do you do? So there are a number of methods that you can use. Let's see which one. So you can go right with direct multiplication, or you can just use that matrix method. So I'll go ahead and make a 3 by 3 matrix using this. So the first row, of course, is for I, J, K. Then the first term in the cross is RBA, so it will come first. And for this one, we have these here. So those will follow here. So you don't need the unit vectors for these, so I'm removing these. And no need for this plus here. Next, I need the other one, which is RBC. RBC, this is the one here. And just actually write it down to avoid the hassle. It's 5.08 minus 4.1 minus 2.4. At this point, let's perform the cross product. So again, in this method, cross product is done as if you're just getting the determinant of a 3 by 3 matrix, as you have seen. So the answer will be, as it goes, first do this and that. So here you're doing it for I. And this is going to be minus 6.6 multiplying minus 2.4. What do we get? Now that we have done this, we can now just simplify. What will be this? Okay, just a minute. Any questions so far?
Yes, please. Can you just get back on this last point? Where we're using the sharing the direction, using it to get the unit vector.
Okay.
A recap on that.
Yes. So what are you?
34.
34.
Wait.
34. Okay, so you guys can verify this. So when you get the magnitude, you get 34.34. So now we can bring it here. Remember, it's the vector itself divided by its magnitude. So we can now conclude that the unit vector will be equal to the vector itself, which is this, then divided by the magnitude. And remember, the magnitude we were just from finding that 34.34. We can leave it like that, or we can say 22.4 over 34.34 I plus 15.52 over 34.34. You can still divide and express these in decimals, by the way. Then this will be 20.9 divided by 34.34 K. This is what will give you the unit vector U. Now, why did we need the unit vector? So that we can get the force that they want us to find, F. And the force F is the unit vector U multiplying the force F. So it's the unit vector multiplying the force as well. So it's a unit vector, but this unit vector has to be in the direction of the force. So this is how we are going to get the force. So I've already done everything. That's why here I am now just describing what you need to do. So this will give you the force as a vector. Once you get the force as a vector, you can now get the moment by cross product. I remember we got it was from D to B. Now cross the force that we have found from here. This will give you the moment M.